All right, let's go. So tell me what you know about IVs then, without that being said. Thank you. What do you know? Yeah. In so many ways. It is Christmas time, you know? Come on.
Critical pre-hospital skill.
It can be, depending on, right? But certainly one of the things we need to be good at, right? Yeah. What else?
You need to understand the applications down the road.
What do you mean?
Well, for like CBA cases, if you're not going to use a 16 or a 14 gauge needle, then usually they just have to put it in a different ID access for that.
Okay. What else? You're right. What else?
Sugar considerations.
Okay. So depending on the medication, what I hear you saying, Trevor, depending on the medication, you can create some other problems along the way, right? So necrosis with B50 is the bad one. So there's a number of other ones out there. What else? So sometimes yes and sometimes no, but what I hear you saying, Craig, is that you want to be careful of the rates that you're running it, depending on your patient condition, right? Yeah, I appreciate that. What else? Why do we start IVs? We talked about it earlier today. The idea is just because, well, that's what we did, right? So the idea that we're going to talk about 4 or 5 different reasons as to why we start IVs along the way, outside the fact that that's just what we do.
It's a cool skill that you were given, so you might as well.
You know what? The reality is there's probably some truth in that. I mean, if we're being honest with ourselves, there's probably some truth in that, right? That's just one of the things that we're proficient at, and so we should be able to do that. Okay. What else? Are there any complications from it outside of necrosis with B50? Yeah. How fast do we run IVs? So I'm going to put some pain here this afternoon, and you're going to have to learn a way. Learn formula, the first formula, the last formula. And so the idea that we're going to be working out the formula. And while it's not practical in the pre-hospital setting that we're necessarily working out the formula, for national curriculum, you need to know about a formula, so that we'll be talking about it as well. Okay? So let's go. We're going to talk a little bit about indications for IV access. We're going to talk about types of. We're going to talk about IV equipment and fluids. We're going to talk a little bit about prep and technique, complications, flow rates, drug administration, and more about fluid resuscitation. At the very tail end of this thing, I'm going to sidetrack you some weeks, especially if you quote. We're going to go into much greater detail about what's happened over a period of time. Started getting IV fluids, and so it's way, way different from where it was 15 or 20, even 20 years ago. The idea of what we're doing with IV fluids and running them, not running them, is very much different from yesteryear. I'll tell you about the tales of woe. So indications, you should know this. You should know that we're going to start an IV because of the possibility of giving fluid or blood replacement. So we're thinking about treating that shock. The idea for drug administration, you already know that parenterosis we've been talking about this afternoon. We do it to obtain blood specimens for lab analysis. And we do it for probably the most typical thing, proactively, because we think it's going to be used in hospital. And I get that, and been guilty and been busted for years and years of doing the same thing. But the idea, we just need to be smart about starting IVs and when to do it. So from a pre-hospital side, peripheral or intraosseous is certainly the most common. Although not so long ago, there were certain central lines that were starting in the pre-hospital side, but we've kind of gotten away from that. With the central venous, we're talking about veins that are located deep within the body. The two that we could start yesteryear was an IJ sometimes, in some cases, and sometimes it's subclavian that goes across the chest. Not so much for femoral from the pre-hospital side, but pretty much these are gone by the wayside and started being in the pre-hospital setting. So there are PICC lines for those that are cancer patients or immune suppressed or renal failure or the likes of. That are put in place because of, instead of having to stick them all the time. Larger veins that will not collapse in shock is the real advantage in terms of central lines. So when we talk about supplies that are needed, for those of you that have not started IV or have a lot of experience in doing it, the idea that we're going to set up a solution. And that solution can be, the solution is typically going to be either lactated ringers or it's going to be safe. Rarely will it be P5 SARS I'm going to stay wide both this afternoon and tomorrow as we talk about blood light balance. It's why I'm not using P5 along the way. So we're using an IV solution. Yes.
Dopamine is generally in P5 building.
But dopamine is given only as a secondary drug, not as a primary drug. Okay. So yes, the answer to that is yes. So we've got IV fluid. We've got our administration set. So tell me about something about administration sets. So what's the difference between the two of them?
10 or 60 drips per minute.
So 10 macro is 10 or 15 drops per minute, whereas micro is 60 drops per minute. Okay, so 60 cc's or 60 drops per minute is what we're talking about. Okay, when would you use one versus the other?
Is it a lot of fluid or just a slower,
Okay.
more controlled?
Okay. So generally, if we're talking about fluid restricted with geriatric or pediatric, then it might be a good idea to go with microtubing. Whereas macrotubing is we want to run fluids or different population along the way, right? Okay. Tourniquet is needed. Alcohol betadine is needed. IV catheter is needed. We'll talk more about those. Offsite or tegaderm, sometimes you hear both. 4x4, if you happen to be somebody by the name of Gary, then you need Chuck just because he tends to be a slob. So IV fluids all by itself. Check this out. You're gonna get this afternoon. You're gonna get this again tomorrow. So I will slow the bus down so we can actually talk about this a little bit. There's a difference between something that's called colloids versus crystalloids. The IV fluids that we end up getting is crystalloids. There's plenty of other solutions that are out there. They're called colloids. And the difference being is that one is easy to cross the cell membrane, the other one not so much. Colloids are a large molecule that will remain in the vascular system for a long, long period of time. And so plasminate, fresh fluid plasminate is a good example of that. Albumin is another good example of that. Generally not in the pre-hospital side. We see much of it in terms of colloids. Although there is always some ongoing research and ongoing controversy in terms of some things that they're trying to put into the pre-hospital side that's going to last and assist them longer. Crystalloids, on the other hand, is the stuff that we do use every single day. I'll let you write and then we'll talk. So there's a good news, bad news about crystalloids. Crystalloids will flow across the cell membranes very, very easily. It's considered to be an isotonic solution, okay, right here, isotonic solution, and ringers or normal saline are typically considered to be isotonic solutions. So there are some differences between saline and ringers, but we're not going to get into that right now. The difference being, primary difference is that it's got some more electrolyte in it than does normal saline. 2/3, check this out, 2/3 of infused crystalloid fluid leaves the vascular space within 1 hour. What does that say to you?
Well, if you're using it just for hypertension, you're losing a lot of your fluid.
Okay. Does any of the crystalloid solutions last for very long? Very, very short term. It crosses cell membrane, has its effect, does its thing, and it's gone. So it gets dissolved, it goes through the kidneys like we've been talking about, or like we talked about a couple of weeks ago. The idea that it's pushed up to the kidneys in a very, very short period of time. But in the meantime, it has a temporary effect on somebody that's shocked, right? So one of the big reasons that we give crystallized fluid is because somebody's in shock or somebody's dehydrated. And so over a short period of time, we can do something in terms of trying to reverse that. But a longer period of time, it's not going to be crystallized. That's the reason that you end up, you hang your 0.9 saline in the hospital, and they almost immediately will end up hanging a different type of bag to try to stabilize this much more than what we can do. You need to know the difference between isotonic versus hypertonic versus hypotonic. You'll see it this afternoon, you'll see it tomorrow morning, you'll see it on Wednesday as well. Okay? Between the three, you need to know it. Isotonic means that it's equal on both sides. So the whole thing, by using diffusion and osmosis, the whole thing is very just fluid across the cell membrane, one way or the other, to be equal. So homeostasis at a triangle, if you will. Hypertonic shifts fluid from the intracellular to the intracellular compartment to the intercellular to the extracellular compartment. Should be extracellular right here. Okay. So intracellular to extracellular. So B50 is a good example of hypertonic. It's not the only one out there. Typically, from a hospital standpoint, we don't carry a whole lot of hypertonic solutions. Now, tomorrow morning when we talk about electrolytes, this can happen all by itself. This whole swing in terms of these three different things can happen all by itself. What we're talking about this afternoon, however, is by using fluids to kind of force that. Hypotonic solution causes fluid shift from the intracellular to the, yeah, thank you, to the extracellular compartment. B5 is a good example of that. Go back and take a look. That's fine. Say again.
Are those reversed?
Yes, they are.
Oh, okay.
Sorry about that.
Wait, what was reversed?
The hypertonic versus the hypotonic. Okay.
So hypertonic causes them to go into the cell?
Hypertonic causes it to go outside of the cell. Okay. The whole thing about hypertonic causes it to go outside the cell. This causes it to go inside the cell.
Gotcha.
All right, so other fluids that are out there is blood. So there are a couple of places around the United States, in the pre-hospital side, that are starting to carry blood. I just read something recently, I think it's down in Texas, to where they're very, very proud of themselves for starting to carry blood on an ongoing basis. But carrying blood is a perfect solution, as we're going to talk about when we get into the fluids later on. The idea in terms of giving blood in the pre-hospital side is the pain in the blood.
It's going to become more common with that, but the high stats.
Now, I think the high stats will certainly help that, but it's the blood itself. And there's so many streams about the blood itself, it makes it difficult. So the isotonic solution that we were just talking about, it comes from, it can be as small as like 50 mils or 75 mils up through 1,000 cc's. What we carry in the pre-hospital setting is either a 500 mil or 1,000 mil, and part of that is just because it's cheaper. Part of that is because it's the starting point for giving IV solutions. Within an IV bag, you're going to have the fluid itself in terms of whatever it is, and with an expiration date to it. There's going to be a lot number. The lot number is about that if the whole thing goes bad or recalls the alcohol, they can pull that on the drug. It actually happens on a fairly efficient basis, but they end up recalling IV fluids. There is a medication administration port. There is a administration set itself. So within this bag, actually, on this bag, that happens to be the port right here. So the normal setup would be that you're going to put your administration setting for this right here. You were going to add medication port to this right here, which is the most unusual setup. Typically, what you have is two different ports in the sitting right here. And that's typical setup right there. So by now you should start to get the idea that we're going to check check for an expiration date. We're going to make sure that there's no leaks around it. That is, but you usually come in out of wrapper along the way. You can sometimes see some fluids that are leaked out of that. You don't want to use that bag at that point. There are some bags that can that can sweat, and so you might see a little bit of condensation on it, but and that by itself is no big deal. As you hold the bag up, the idea that you're going to look for any chunks within the fluid itself, you would not use that. Make sure the solution is not yellow, so it's clear. So it should be at room temperature or warm. As we get into shock, and talking about shock in a couple of weeks, the idea of that giving warm solutions for somebody in shock is a much, much better outcome for these patients. Although, for the most part, we don't have the ability to do so. This is open for discussion. If open and spike good for up to 8 hours, there's no research that says that 7.5 hours versus 9 hours that it does any better as far as that IV solution being contaminated. That's just kind of the rule of thumb.
Isn't there something also on how it can sit on the warmer?
Most will say on the warmer that it's good for about 2 weeks or so and rotating it out. But again, I don't know if there's any research that points that out as a good thing. What?
We literally never rotate them out for one.
Yeah,
You guys should really sell it to AMR here.
it's a great company. But you want to know why that is? Well, most protocols will say 2 weeks. There's nothing that indicates that it does any better than 2 weeks or 2 months or 2 years, right? All right, so do not miss this, folks. The difference between macro drip and micro drip is that this is either 10 or 15 drops. So you see GTTS, that's drops. 10 drops equals 1 mil for giving a large amount of fluid, and they also come in 15 drops as well. Okay? So you can see it either way in terms of considered to be macro, drip, micro. We already talked about, but the idea is we're going to have 60 drops equals 1 mil. And again, you're going to use this either for restricted fluids or that you want to do something special with it within tubing. We talk about measured volume. We're talking about putting something in line that measures the amount that you're going to give. It's going to restrict the amount that you're going to give. You set it at a given amount, right? And it's going to do this outside of the pump. So this is another device that can be put in line. And finally, blood tubing is a wee bit different in terms of it's going to have a filter on it. And the other thing about it is it's going to be non-collapsible. The administration sets here are definitely collapsible. So it's not so much. It's much firmer. In many cases, we're putting the IV extension tubing in place. The reason for that is that we can do something different with running the IV fluid, and we can do a number of different things along the way that makes it a better setup. The other thing is, let me go forward for just a second here. Let me see if I have it or not. The other thing that's out there that many of you would not carry, but is real advantageous if you do. And that's this. So this setup would go, this would hook into your bag. This has about 100 cc chamber on it. You drip the fluid in off that 100 cc chamber, so you can be very, very clear how much fluid that you're using on the way. This is called IVIIO. And so the nice thing about it is pediatrics. The nice thing about it is if you want to run a specific amount in case you go all the way, if you mix a bag, you want to run a specific amount in here, your trouble will be really handy in terms of using it. So many of you will not carry it, but it's out there. It's another nice to have as far as being fluid restricted on the way. If you end up doing interfacility transport, you might end up using a pump for that, but generally not so much. And that's exactly what we just got finished talking about in terms of administrations and everything else like that. Macro versus micro. So in terms of IV catheters, the hollow needle catheter is the one that we use most often. What we talk about, sometimes called angiocath. The idea in terms of like butterfly is another way of using that. So what's our largest size catheter that we normally carry in the pre-hospital side? 14. So generally a 14. Every now and then you'll see a 12 up there, and the smallest being 4, right? What's the other thing you're looking for outside just the size itself? So it goes from 14 to 24 gauge. 14 obviously being bigger, right? 24 being smaller. Why does the length matter? That's not.
That's what we hear.
Right answer. For the wrong reason, but right answer. Or something else. What determines as to how fast you can run your IV fluid? You would say size, right? So those of you that are with fire, what happens when you end up having a lot of holes you have to run water? You get friction loss somewhere along the way? It's exactly the same thing. That's what we're talking about. So not only is it about the size bore, but it's also about the length of the needle along the way. Wall, exception, so if you end up getting blood, you're probably going to get a 10 gauge or 12 gauge along the way. But the idea that when we start talking about large bore IV, if we're talking about adult, we're talking about somewhere between a 14 and 18. We're talking about pediatrics, then we're probably talking about an 18 on up from there. This is the law you need to know. Write it down. Remember that. So essentially what this is saying is if you want to run a bunch of fluids and you want to make a difference in terms of running those fluids, not only do you want to go with a large bore IV catheter, but you want to go with a short large bore catheter. You can see the numbers up there in terms of calculation of the height. So to that point, the other factor that can have a bearing on this is if you have a big old long administration set, like a 96-inch administration set, it's going to have a bearing in terms of how fast it will run. The size of the vein all by itself is going to have a bearing on it. Viscosity means the thickness of your fluids. If your fluids are cold, then it's going to run slower along the way. And then the height of your administration set would be the other thing that has a bearing. All these have a play in terms of how much fluid that you're going to get on board. So over the needle catheter or angiocath, depending on. Butterfly for blood draws, butterflies sometimes for pediatrics. Butterflies in terms of, you know, if you want to. Butterflies also in terms of primarily in hospital. The problem with using butterflies in the pre-hospital side is they don't play so well prior to getting taken down and secured in the pre-hospital side, especially with all the movements that we do with our patients on the way. But they work well, and I mean they do a pretty good job of running fluids as well. It's just that securing them sometimes is difficult. This is something that's considered to be catheter inserted within the needle itself. And so this metal port just kind of splits away from around the catheter itself. So as we get started tomorrow, as far as doing our IV6 and everything else like that, the idea of a perfect IV site, it's all over the place. And so we sometimes focus on the ACs, and yet not always the best place to start. And so we'll start playing with a number of different possibilities as you go on. If we're talking about pediatrics, scalp veins will work pretty well, not so much on the adult side. If we're talking about external jugular, works very, very well in terms of a large vessel, but we'll talk about the downsides to that as we go. Feet, yes, but careful in terms of the population that you're doing IV for, and that is especially diabetics or immune suppressed, that it doesn't work so well as far as long term with the IV needle there.
Isn't there also possibilities of thrombosis?
Yeah. Yeah, but the kicker is that IV catheter has to be in for several days before it starts becoming an issue for that. But the answer is yes.
And isn't it 24 hours that you have to clean valves?
48 hours.
Is it 48?
Yeah, most in-hospitals say 48 hours. But the thing is, a lot of hospitals will do it almost automatically just because they wonder about our infection techniques. So just some tricks along the way. You're going to discover this, and we'll start dabbling with this tomorrow. Using a tourniquet to help the vein, not to occlude it completely. You can also use a BP cup along the way, and there's a number of different devices out there that will allow you to do that. Lower the extremity below the level of the heart. Apply heat to the area. In some cases, will help palpate for the vein. So the idea that you're always going to get this great vein that stands up and says, "Hit me." The idea that you might be able to palpate it and kind of have an idea of where it's at. Start low and work proximal. The idea of starting in the hands and working up from there is the ideal. Unfortunately, we don't work in the ideal, so that if we're in a hurry, then a lot of times we just go to the AC and work from there. So what's a valve? For the 6 of you that have done IVs before, what's a valve?
It's something in the vein that stops your blood back going back down the extremity.
Okay.
And your IV can get down that bottom.
Okay. So the idea to where you look at a vein and it comes to like a Y type of shape is a valve. Guarantee a valve, you say that. The idea that once you put a needle through that valve, it will not flow easily. So try to normally the valve with the ball pump. Get above it. You see geriatric populations where veins look like a road map, right? So it's all over the place, and so sometimes not easy to start that. Veins near joints, so the wrist, sometimes the AC is going to be a problem for you, and try to avoid that as much as possible. Veins near injured sites. So check this out. Does that mean then that we can't do IVs through burn sites? I'm telling you right now, I'm loading you up in terms of this question. Can we do IVs through burns? Yes. As a matter of fact, yes. The idea that it's not ideal, and you want to stay away from it if at all possible. The idea that because of the need for fluids and maybe burns, the idea of starting, the idea of starting IVs during that will take precedence over it. So as much as possible, trying to avoid the affected side where mastectomy or a former stroke patient is an issue. I will tell you though, in talking with Dr. Garrity in the last year or so, she doesn't have a huge issue about us starting IVs on the affected side of previous stroke patients. And so you'll hear that a little bit more from that.
What's the deal with mastectomy?
So the idea is it's supposed to be reduced circulation, reduced lymph nodes in that side, and so it comes back to that. And again, there is a couple of different papers out there that indicate that it probably created an issue, but that was probably a decade ago, and I don't know if there's been any current stuff about that one way or the other about it. And this is just talking about different veins along the way. So that the tourniquet should be you should be able to get your fingers underneath that tourniquet, not so tight that you're going to totally close it off. Cleaning the site with alcohol. You want to be careful in terms of you can use alcohol, betadine alcohol to clean it well. The idea that iodine, for some folks are allergic to it, so you need to know that with your patient population. Going in with over the hollow type catheter, the idea of going in, some will go in as what's considered to be a low approach, others will go in with a high approach and then lower down. And so we'll play with that tomorrow. We'll start playing that with that as we go. And so the perfect angle is typically to go in at about 15 to 20 degree angle, and then just move forward from there. Now they've got a flash here in terms of this catheter, and so it gets a little bit to the point where you have to have some good technique that once you start to see a flash, that you're going to move it forward about 1/4 of an inch as you're pulling back on the needle portion of this. In this case, they're pulling out blood as well, and then hooking up fluids at that point. The idea that you've gotten rid of the tourniquet, once you start to do that, you start to run fluids. We're going to tape it in place well. We're going to typically we're going to use a sterile type dressing, like a tegaderm type dressing. There's different ways that you can do it in terms of tape and sterile 2x2.
Does Tegaderm have any antiseptic at all?
I'm sorry, say it again?
Does a Tegaderm have any antiseptic?
No, it's just sterile dressing, that's all.
All according to what you put.
So what they're showing here is just that you're who the idea is on and what time you started it and date and everything like that. So in terms of flow rates, you can run it at a KVO, keep vein open. You can run it wide open. You can run it with devices along the line, so you actually put it in line as far as how you run it. I showed you the bureau trawl, how you pump it out there, or calculated rates. Let's camp here and talk about this. You need to write this, and then we'll talk. Okay, so it looks something like this. If you want to run 125 cc's an hour, you got a 10 drip set. You always do it in terms of minutes, not hours, always minutes. So if this is an hour and a half, then you go 90 minutes. If this is 2 hours, then you go 120 minutes, always in terms of minutes, okay? So somebody do the math, what'd you get? Yeah, so right around 21 drops per minute. So to that, the idea, like I was telling you earlier, the idea that it's probably not practical unless you happen to be doing in-facility type transports, that you would get down to this. But nevertheless, this is one of the things for curriculum purposes that you need to know about, okay? I'm going to give you a worksheet this afternoon that's all about this. That will be due next month. Questions about this? So what are factors that are going to restrict our flow rates? Well, by far, the most common one that some of you will be busted for is the fact that the tourniquet's in place. Not that that would ever happen here, but I'm just telling you that happens here, okay? So the idea that is probably first and foremost. Edema at the puncture site. So the idea that they've got CHF, they've already got peripheral edema that's sitting right there, will slow it down in terms of trying to push as much fluid down that person. Cannula is butting up against the vein wall or a valve. We kind of talked about the valve earlier on, but the same thing can be true in terms of the vein wall. Sometimes just pulling back on that will allow fluids to start flowing again. Sometimes very, very temperamental, depending on where you have the cannula at. Administration set control valve. That is that with that administration set, if you have blocked off in terms of thumb wheel, or you have it blocked off in terms of a number of different clamps along the way, it will do the same thing in terms of not running your fluids. IV height. We talked about the idea that if you've got this sitting on your patient instead of at some height, it's going to start backing up, especially if you have a fairly decent vein. If your drip chamber is completely filled, that is, if your drip chamber is like up to here, you're not going to notice whether or not that's truly full. Okay, so we'll show you some tricks in terms of getting rid of that. It can be because you're infiltrated as far as your catheter. It can be because tubing is kinked along the way. And again, IV bag height is there twice, the same thing. And finally, again, infiltrated, your line is no longer good. You no longer good. So IV access complications. Where different complications along the way? Well, we can have it in terms of pain. So should your patient be in pain once the IV is started? Generally, it's not really a big deal. Once it's started and pulling or anything up like that, like good. If it's a continuous type painful thing, you should question whether or not the catheter is good or not. Local infection. So are we going to see local infection in our short period of time with it? Probably not, right? But in hospitals, this is one of the reasons I was mentioning earlier on. This is one of the reasons why they all automatically switch over to starting their own IV, because that way they have some control in terms of their technique and how long it's done and everything else like that. Pyrogenic reaction, what's that? It is heat, but more than that. It's your patient's running fever. It's some sort of infiltration because of our technique, because of the infection in the area, they start running temperature. Sometimes it can be very dramatic, and sometimes it can be very quick. And so it's possible, depending on how long you have your patient, it's possible for you to see some of this. They can have allergic reaction to iodine. They can have allergic reaction to tape. They can have allergic reaction to sometimes the catheter itself. And so it's all possibility. What's catheter shear?
Catheter starts breaking apart.
How does it do that?
So if you don't pull, when you advance, if you don't pull the needle out, you can actually shear, right? Or they can actually get a piece of the plastic catheter in them.
So as Christian is talking about, the idea that it has a plastic portion as far as its catheter. See if I can do this on purpose without stabbing myself. So what we're talking about, folks, is you have this plastic portion here, and you have the needle itself. And sometimes what happens is that by pushing and pulling and pulling back and everything else like that, this needle will actually shear on the plastic portion. So there's like a shearing of the plastic portion. And so bits and pieces of that can actually flow, free flow, up into the heart. But again, not cool thing for the outcome of your patient. Okay? So when we talk about catheter shear, that's what we're talking about. It can happen when we go to put it in. It can happen in terms of pulling it back out again. This can be the idea.
Would you say the most common reason that happens is just when people kind of going in and out, digging around and pulling their needle in and out?
Exactly what it is. So the other thing about catheter shear is that when you go to discontinue an IV, not that we would do that very often, but when you go to discontinue an IV, take a look at your IV catheter. That's intact. It wasn't sheared along the way. If it was, that's something to report to the other end. Inadvertent arterial function, never would that happen here in Spokane. Okay? That's over in North Idaho somewhere, not here. How would that happen?
You look at somebody's wrist and you see a nice looking vein right there. It goes slightly too deep in there.
Slightly too deep in the understatement. Okay? The idea that typically those that go with a high angle and come down to the skin. In other words, you're coming down this angle right here, and you happen to be along the radius side, there's a good chance that you're probably going to end up with an arterial stick. You're going to know immediately in terms of what, and you know. Yes, right, ladies, it's going to be panicking, so you're not just concerned about the bright red, okay? So the pulsating blood that's coming back, you can't stop any other way. It's a pretty good indication. is not working. Okay? No, okay? Circulatory overload. What are we talking about? Because we're sometimes give discharge.
Give them too much fluid.
Why would we do that?
Because
Why would we cause circulatory overload? Yeah, there's that. Right? You get busy with something else along the way, and you meant to run in 200 cc's, and now it's at 500 cc's along the way. And they never upward stress to cover that. Okay? So the idea in terms of that. So catch something else here. Sometimes you're between a rock and a hard place. So you were telling me earlier on that you do not want to give for somebody with congestive heart failure. I'm here to tell you there will be times you give fluids for somebody with congestive heart failure. For somebody with a blood pressure of 70 or 60 that's tanky, and they happen to be wet in the lungs, what's your option? Not great. So the idea of giving a small fluid bolus along the way still can end up putting into circulatory overload. So even in your best case scenario, when you are being careful about it, you might get stuck between that rock and a hard place. Welcome to the big one. Thermal phlebitis, what's that? Yeah, what does it look like? Red, it's got this red streak going up that vein. So wherever that vein is headed to is where that streak is going to be headed to. And so that becomes hot over a period of time. Typically in the pre-hospital side, you will not see trouble phlebitis. In hospital, definitely. So what goes to the hospital folks will let you know. So to that, they end up running this fever that goes along with it. To what you were telling me earlier on, the idea that you can create a thrombus, especially in the lower extremities, but typically that's what we were going to be over days and not just hours. How is it that we run air embolism? Because I love this. Okay. So how much air does it take in order to get to an air embolism? The idea in terms of what causes, and they've actually done some models about this. The idea in terms of what causes air embolism would take this to this to create an air embolism. Nevertheless, you want to be the person that says, "Oops, I got flushed out along the way. Look what I did," right? So the idea that we get real crazy about getting rid of all these things. Is good practice. Is it needed? Probably not. Folks can do very, very well with some small goals along the way. Okay? So you do your best practice in terms of trying to get rid of as much as possible. But don't spend the next 5 minutes trying to get off all this. Exactly. Metallic necrosis. So we were talking necrosis a little bit earlier on. Necrosis is hard because of medications that we give along the way, but also necrosis in terms of running an infiltrated line and continuing to run it around. It can be necrotic around that tissue area by running IV fluid. It may not seem like a whole lot, but the idea is that this becomes swollen and tangled and stuff like that. Then over a period of time, talking about 24 to 48 hours, this starts sloughing off in terms of that tissue. You think you can get busted for a line that you don't catch along the way. Infiltrated? And absolutely, same way. So yeah, that's probably one of the bigger things. Yes. So mentioned this earlier on. This presentation is older, so this is 72 hours. Generally, these days, it's about 48 hours in terms of being changed out, at least. When do we stand up last? 25 minutes. An hour ago? All right. 5 minutes. Come on. I'm okay. I'm looking at glassy eyes. You're sliced up.
Close out with that great break.
Sometimes depending on how much
So, I exactly. So, you feel like you get in there, you gotta get out.
yeah. Kick her
I guess you probably want to try to do a blood draw that.
Right. Yeah.
I think
continue on with this. We're talking about EJ, external jugular vein. No difference with the exception of this big old honking vein. The idea, thank you, the idea in terms of pulling up that EJ is that we tip the head to one side. So who automatically is now part of getting EJ?
C-spine.
C-spine, right? So obviously the idea in terms of tipping the head to one side, so you can actually start to palpate for that external jugular. The idea in terms jugular is going to go right along in here. So don't be fooled with it. Typically, you're not going to get this great outflow with internal jugular. There's external jugular that you will. So the idea of stretching the head to one side taught that you actually are pulling up in that vein. Some other tricks along the way that we'll teach you is that your Dellenberg does help as far as getting the feet up towards the head. So again, you want to be careful in terms of head injury, right? What's the downside to using this vein? Because there is a huge downside. It's a great vein, right?
Sea colors.
Yeah, we already kind of talked about that, though. What's the downside to it?
Isn't that in the way? You're all done.
So I'm hearing about air embolism. That's a possibility. I'm sorry, what did you say?
Your IV set's all in the way.
That's part of it right there. The idea, think about this area right here. If you have a critical patient, you're bound to have something in terms of airway, right? So let's suppose just by having chance that you blow this vein. Can it occlude cross in terms of trachea? Absolutely. So the idea in terms of the downside is that it can have ramifications as far as the airway itself. Great vein, great site, works well. Just want to be real careful about making sure that you get it.
Wouldn't you try to go IO?
Absolutely. These days we do. Yesteryear, this was one of the primary things that we did. But these days with IO, not so much. Still, it's a great place, and we'll get you set up for it as well. So we're cleaning it. The one other difference is that and what he's doing, he's just tamping out at the low, so that remember that blood is coming back to the heart in this direction right here. So he's just tamping out below, so this will kind of stand up for you. And so the other difference is that we're going to come in this direction back towards the heart, not going up in the opposite direction, back to the heart. You do want to be careful in terms of that. You already told me about the possibility of air, but using good technique, it's a primary place where you use a possibility. So we can make exceptions to some of you.
Why is it more likely to have air embolism?
It's no different really than a peripheral thing. The only difference is that it's proximity back to the heart. That's all it is. Shorter thing. So they talk about a 10-degree or 30-degree angle, and that, again, the angle that you're coming into the skin at. That's all it is. So I threw this in just because of what we were doing in years past. It used to be the one other central line, or the central line that we can use was subclavian. And so the subclavian vein and artery run right across the chest. And it used to be really, really sweet in terms of using that subclavian vein, in part because of proximity to the heart, but also because it was a separate vein that did not collapse. And that's kind of gone by the wayside. But in hospital, you see this on a relative basis. All right, real quickly. Heparin saline locks. The idea that we do not run enough fluids on all of our patients is about heparin saline locks. Well, in hospital, you can have a saline lock. Most of what we're doing on the pre-hospital side is a saline instead. So in hospital, heparin. Out of hospital, typically we're going to push saline. And you can use this in terms of port. So this would get hooked right into your, there we go. So this would just get twisted into your IV catheter itself. And off of that, then you're going to run saline to keep that IV intact. So instead of running a bunch of fluids on that, you can use saline to use it as a rinsing thing. So that when you have them in place, if you want to run medication without running a bunch of fluid, this is a good way of doing that. The other way you can do it is that we've got extension tubing. Let me show you that real quickly. We've got extension tubing that you can use, which looks like this. And so it'd be the same thing in terms of hooking this to your IV catheter, and then just running saline off of that as far as keeping it intact. Okay? Lots and lots of different advantages to using this without running out of different fluids. If you know that you're going to have to use medication along the way, if you know that it's probably not in your best interest to give them different fluid, this is a different way of doing that that probably works very, very well for your patient. Make sense?
Does the heparin, I had a heparin one. Heparin is just kind of an antibiotic.
They're called it antibiotics. It's used more in hospitals than saline. For us, it's heparin type thing. Saline is more used.
But heparin doesn't affect blood draw, correct?
It can. It can. Okay, and that's what it looks like. Again, what they're showing is that it's got this needle port, and the port that I showed you is needle port as well. And so again, trying to get more to a lower lock is
so in the future, when they want, if they wanted to add fluid, they couldn't just take the lock off. They'd have to pull down.
So what they would end up doing is they would end up tamponading on the IV catheter above it, get rid of this, run your fluid into it at that point. Okay. So I showed you this already, but the Bureautrol is what we're talking about here. And so the idea of sending it to wherever you want, especially if we're talking about pediatrics, so you can filter exact amounts as to what you want to run in. Okay, so changing the IV bag or bottle, the idea that when fluids are all gone, the idea that you want to change it to a different type of solution, so that if you have your bag intact, the idea that you have your bag intact with your IV administration and everything else like that, the idea that once this is empty, you pour it onto this, and as clean as possible, the idea that you disconnect it, you pull the new bag in, you connect it to the new bag, and you start running fluids off of that. The idea that you don't want to drag it, obviously, around the dirt or anything else like that along the way is going to be an issue in terms of where you fluids from that. But all by itself, usually not a real big deal. So we're not going to camp here. The idea in terms of the surgically implanted device, such as for dialysis, such as for cancer treatment, such as, and the list goes on and on. We're not going to hang out here in terms of doing that. Usually it's a surgically implanted thing. The one thing I'll tell you, and as life goes on, we'll talk about it a little bit more. The one thing that I'll tell you is that from a pre-hospital standpoint, using a PICC line or using a surgically implanted device, generally a no-no. But there's qualifications now. We'll talk about it. Just an example of a pump. Another pump. So let's kind of cruise through fluid resuscitation. Tell me what you know about fluid resuscitation, the good news, the bad news, the history of, or anything else like that. But it's quite the story. It's quite the history.
It's good to get some extra pressure in there, but it's
So let me tell you my war story, and then we'll kind of transition into this. My war story is this: that back in yesteryear, the idea that, especially critical patients, if we weren't running 1 to 2 liters of fluids into our patients in the hospital setting, we weren't doing our job. And actually, we got berated for not running enough fluids on these patients. Okay? That was 20 years ago, 25 years ago. Little did we know at the time that we were killing our patients by doing the same. So the history about this is that it started back in World War I, World War II, the idea of running fluids in the hospital setting. They figured out, and especially in World War II and Korea, they figured out that IV fluids actually will save soldiers' life. And so on the military battleground, they started getting IV fluids on a regular basis. So they could get the blood, and the blood was the answer, and always is the answer, always will be the answer, right? So from Korea into Vietnam, if Korea worked well and started getting IV fluids, then getting a little bit more IV fluids in Vietnam more was the answer. So they actually flooded in terms of no respiratory distress. So much so that again, killing patients by overloading the circulatory overload. Okay? So we went to the opposite extreme of Vietnam as far as killing our patients by flu. And so we still didn't get the idea that giving too much fluids was a big deal. Meanwhile, in the pre-hospital setting, came to being that we're doing IV. And so into the 70s and into the 80s, the idea that we're giving a substantial amount of fluid by appropriate. And only did it change starting about the mid-90s that we started looking at some research that says giving too much fluid or giving any fluids at all in the pre-hospital setting probably is killing patients. And so it has taken this long, it's taken 50 years worth of this to get to the point where we are today. And so the story I'm getting ready to tell you is that we've got 180 degrees now to the direction to start getting IV fluids. To the point that we are talking about blood pressure systolic of no greater than 9. And there's a whole lot of talking about math and the equation of math of different day, not today. But the idea in terms of leaving them in a hypotensive state is what you want is severe shock. So the end story is how much fluid do you get? It's based in part on your patient's condition, but also based in part on being smart with your IV fluids. Make sense?
Yeah. So, what about the septic shock?
Completely different story. That's the exception of all this. And there's other exceptions along the way where you do want to get some fluid, but generally that's the story. Okay. So that's part of it, yeah. So I say all that to get rid of about 15 to 20 slides. Okay, so I'm not This was the part that I was telling you about in terms of they were giving so much fluids along the way that they were creating congestive heart failure. They were creating flash pulmonary edema based on the amount of fluid they were giving during Vietnam. So the idea of what we always thought to give IV fluid for was that we're going to treat the organ and organ along the way. And there's some discussion about that it actually makes a difference. But remember, isotonic solutions is only going to be for a short period of time, right? That's what we're talking about. The idea in terms of us having a great effect on this, not so much the case. So to the point of today that we're definitely questioning this approach. Not only are we questioning it, but but it ends up in a court of law because it's giving too much IV fluid along the way. So there's something that's called reperfusion injury concept. You should know this. So reperfusion is about giving a bunch of fluids and then also a bunch of oxygen along the way for somebody that's in an anaerobic metabolism, i.e. acid-base metabolism. And so the idea that once we throw a bunch of fluids into somebody that's really, really shocky, we're actually going to make this work, and part of killing the cell level. Not doing with IVs per se, but there's another paradox that goes on with oxygen. This is where we give too much oxygen for somebody that's in severe shock. And so again, that will be a different day that we're talking about that. But these two together make a difference in terms of how well our shock patients are resuscitated. So that's kind of putting these two together. So then what's the perfect IV solution? Blood. But again, carrying blood in the hospital setting is clumsy and fast and really, really difficult at worst. College we talked about earlier on. There was some that was used during Iraq and Afghanistan. So this is just kind of what we talked about. The idea that whole blood is our first choice for somebody with hemorrhagic shock, but obviously it doesn't work out that way. So we get way down here with you and me in terms of what we're carrying. And so while that works in temporary needs in hospital, it works in something else along the way. So this is old, but it still applies. There was a first research that was done in the mid-1990s out of Houston, the pre-hospital side there, Dr. Paul Pepe, did the study. And so it was the first time that really pre-hospital side was identified as being a problem. And ever since then, it continues to be a problem to the point where docs today are ostracizing us for giving a bunch of fluids to the hospital side. Just know that's part of your menu. Don't even know this. This is just some things that are out there. We talked earlier about hypertonic solution, and this is an example of hypertonic solution that they can be given to force across the cell membrane. So again, just playing with IV fluid. They've been playing with fluid for a long time. They've been playing with fluid now for 20 years to try and get to something better for the pre-hospital side. They haven't gotten there yet. Still the same. All right, so questions at all on IV therapy for what we've been talking about, okay? Do not miss. You need to know the indications. You need to know the complications. You need to know the issues as to why an IV may not flow. You need to know about a solid flow that we talked about. You need to know about how we're going to set it up and everything else like that. At some point in time, I'm going to ask you to set up an IV for me on a test. Okay? All right, let's talk a little bit about IO. What's your experience there with IO? So has anybody done? You know, 1, 2, 3, 4. Okay. So the idea in terms of IO, splendid way of getting a line in a hurry. The idea that you can have a line within 30 seconds or so once you start figuring out what you're doing. Okay. So we're going to start talking a little bit about IOs from where we came from. So again, because the old guy is talking to you today, I can tell you about the jam sheeting needle. This right here. So while you probably assume that the IVIIO has always been there, it's only been there for about 10 years. What preceded it was this. This is called the jam sheeting needle. Huh? No, not quite that bad. Close, but not quite that bad. So the idea in terms of prior to the IVIIO, we didn't have, well, the sternal IO had caused just prior to the IVIIO. But prior to that, there was this, and only this. There was a twisting type motion in terms of injuring the bone and everything else like that. And truth be told, it worked okay. Not great, it worked okay. And it was only for pediatrics. So adults did not get IOs along the way. And so jam sheeting needle was kind of standard of care, if you will, 10 to 2 years ago. Right? So I will pass it around. You will be playing with jam sheeting needles over a period of time as a backup. So jam sheeting needles is where we came from, and then this bone injection gun came into being, and the FAST came into being. This is the sternal device, and then the IVIIO came into being as well. And all these have been around. These three have been around for about the last decade or so, as the way to start IO. And what has happened because of these three is that this is largely gone by the wayside, and these three have kind of become the standard of care. No, actually it's not. There's another one I'm going to show you that we just got introduced to. Boundtree has had it on the market for about a year or so. That kind of is the same type of thing, but a wee bit different. So there's just something else about it. So with it, jam sheeting needle, true, we were using brute force to get it in place. The idea that we were hoping that it went in, the idea that limited training and vague descriptions had a problem in terms of not using IOs. So that's hard to see, isn't it? So who needs it? Who needs an IO?
Patient you can't get an idea.
Okay, so does that mean that every IV can't get peripheral gets an IO? So critical, right? You need a patient who needs a line, who needs peripheral access right now, is a prime candidate for doing IO on. So the idea behind that is your critical type patients that you can't catch up with any other way. Kind of indications, you should know this. With a fracture to that bone that you're going in now. Previous orthopedic procedures near the insertion site can be a prosthetic limb or joint. I'm just telling you that doesn't flow well. Or an IO that was there in the past 24 hours. So what about sepsis? What do you think? Sepsis in that site also would be another common indication. Okay? So these plus sepsis in that site or infection in that site.
Okay. Is it just like a deeper into more?
Yeah. If there's a history where they had an IO there, or there's a history in terms of infection, I probably would say that.
It's a septic teaching.
Um,
Is that just a,
if it's a septic patient, you can't get an IV any other way as a last resort, I would consider it. But it probably wouldn't be my primary. You guys okay with this? Can I go? Also, just got finished talking about infection or inability to locate landmarks or assess the tissue. Who are we talking about? The obesity. And so the idea in terms of trying to get a site for the 3 different sites for the IVIIO that we're talking about is a real hindrance. Sometimes a real issue in terms of trying to get it in place. 5 rights at IVIIO: right needle, right site, right amount of lidocaine, right flush, and right amount of pressure. Why do we use lidocaine? We use lidocaine in turtle line. Why would we use it here? Well, it's safe.
It hurts like hell.
Yeah, matter of fact, it does. So check this out. You won't believe me when I'm telling you this, but I've done IVIIO on conscious patients, cardiac arrest patients, and semi-conscious patients. The very first case that I did was a 67-year-old gal that had CHF, was in failure, was getting ready to spiral into cardiac arrest. And so did not have peripheral line to save my life, ended up doing an IVIIO on somebody that was semi-conscious along the way. Never ever did she wince at all in terms of putting that needle in place. But Mr. Let me just tell you about the running of fluids. She came off that gurney. So her own level of consciousness turned into level of consciousness is based on drinking fluid. So lidocaine is kind of part of it in terms of bone marrow. You're dealing with bone marrow, and you're dealing with pushing fluid through that bone marrow. And so the whole thing about the lidocaine goes along with what we're talking about.
Long-term use with use IO, what's their prognosis like on that side?
So it can be in place for about 48 hours, but the idea in terms of the healing all by itself, it generally does well. Also, all by itself, it generally does really well. And that's the same with all of these that we're talking about, all the devices we're talking about.
So it would be more like an product for the issue.
No, not by itself. So it comes with different needles along the way, and it's based on weight, it's based on kilograms. And I'll pass these around.
One more thing, can you do sugar IO?
Yes.
Okay.
No, okay. So 3 different needles. So check this out. This is always considered to be the big honking area, right? I'm here to tell you that the latest thing is that if you're using a humeral head, that the recommendation is that you use this large needle in all cases. I haven't quite got my head around that in terms of that. The last time I did, I used a regular sized needle for a regular sized patient, and it worked okay. But the recommendation is that because of the size of the humerus here, that you use a large needle for that. Okay? So 3 different needles. It's based on weight. You have a pediatric needle, you have a regular sized needle, and then you have what's considered to be a obese needle. That's what you want.
But then the same thing really can't go past or through or
You can go through. It's possible to go through.
with the
Yeah. So the thinking is that there's enough tissue there, even with a smaller person, that that you won't go through. I'm not sure that I trust that.
By the big needle into. Sorry.
So the other thing that you see in those needles is there's marks at the very base. You pull back the capital, you'll see marks in them. Those needles, those marks are intended to be the depth that you go to. So you don't have to go to the hub as far as pushing that through. And that's just exactly what we just got finished talking about. These are the marks that we're talking about right here. Okay, these marks and these marks right here are where it's intended to stop that. And the drill itself should draw it down in terms of telling you that you don't need to go any further along the way. Just showing exactly what we talked about, the idea that goes into the bone marrow. And whoop, come back to this. Come back. There we go. So the idea in terms of going into the bone marrow so that fluids start flowing all the way. So we'll talk about this. I'll show you a video here in just a couple of minutes that into the humor had the idea that the fluids can run very, very quickly back into the heart. So the idea in terms of, we already talked about contraindications for IOs in general. Yeah, the ability to get accessibility to the site certainly is it could be another thing. Desired flow rates. The idea for flow rates is the same as for plant general. The idea is just to put some pressure on it as far as running those fluids, but in the end you can run a fair amount of fluids in a short period of time. So the three that we'll talk about is proximal tibia, medial malleosis or distal tibia, and then proximal humerus. This is with the IVIIO. So the other one that we'll talk about, the sternal IO, is literally sits right here in the in this sternal area. So what they're doing is, and again, we're going to start playing with this tomorrow. In your lab setting tomorrow, we'll start dealing with IOs. And so with that, we're locating tibial tuberosity, which is 2 finger widths down from the bottom of the patella to the kneecap. And we're just going to come to the medial side. Okay, so right in here. Same thing in terms of medial malleosis. So we're going to go just above the ankle bone, medial malleosis, 2 finger widths up on the flat bone side of this until there. On the humerus, with the idea that we're going to take the arm and we're sling it across, that exposes this AC joint right here as far as trying to locate that. We're going to come down 2 finger widths from the cap of that, and we're going to insert on the flat bone. The nice thing, one nice thing that I like about the IVIIO is that when you hear this, the drive are starting to drive down on itself, or starting to back up on itself, is the idea that when you want to stop, it gives you a little bit of sensitivity to that. This is just a stabilizer as far as the needle itself, and we'll play with that tomorrow. So the gun, I'm sure you've had your hands on it before, but the gun attaches to the needle, and it's a simple thing in terms of difference and go on that. And it's just go in the bone. We'll play that tomorrow. The idea that we're coming in at a 90-degree angle to the bone itself. This talks about again the mark that you're stopping at. That once you have the needle in place, the needle should be firm, standing up in the bone. If it's not, then you're not in the right place. So the needle is standing up. You're unscrewing this so that you can actually hook up your IV fluid. And you want to use extension tubing with this. The extension tubing is in part that you can do a number of different things. One of the things we're going to start teaching in this class that we haven't done in the past is using 3-way stopcocks for a number of different reasons to run IV fluids and your medications at the same time. This is just stabilizing the IO. And actually sharps. This is the extension tubing that's in place, and so the idea that when you pull back, when you draw back, in some cases you can get bone marrow fluid that comes off of this. In some cases, a little bit of a tinge of blood, but it gives you another clue that your IO is in the right place. I mentioned this earlier on. The idea in terms of the pain sensors within the bone marrow area, nerves are right in that neck of the woods. Let me tell you, again, your patients will rely. So the thing that we found out is that your first flush should be that lidocaine. Once you know that your IO needle is good and everything else like that, the first flush should be your lidocaine. Typical type dose is 20 to 40 milligrams, and we'll show you how much that is as far as lidocaine along the way. Okay? Nevertheless, even with that, your patients will scream up a pain to start out with. But once you push the lidocaine along the way, and once you start pushing fluids behind that, typically that goes away in terms of severe pain. It's material there, they'll remind you about it, and everything else along the way.
Better to do slower than that, or just
Steady collision, steady collision. And this is exactly what we just got finished talking about. In a rare instance, you might end up using analgesics if you're not using it already for the possibility of pain and sickness. And this is just the lidocaine, and this is just the dose. Okay? They've got 20 to 100. Typically, we'll start with 20 to 40 milligrams, and then we'll try and move that.
last piece of
Yeah, it does. So the idea in terms of pushing this, once you have this in place and everything else like that, and I'm starting to run IV fluid, because you're into the bone marrow area, you have to hook up a pressure infuser. And it's either a sleeve that goes on top of the IV bag itself or a BP cup, either way. But the idea is just to put some pressure behind as far as running the fluid. Past that, and your IV should flow fairly easy. And here's a sleeve right here. If you are going to disconnect for whatever reason, all they're talking about is you come back in a counterclockwise type motion as far as pulling back out again. All right, let's see these play.
Nice, Philly. All right, now we're going to aspirate. Isn't that beautiful?
Okay, so that's bone marrow fluid is what you're looking at. Take a look at the site and everything else like that.
Wow. It was fast. It was
So this is a resin. I'm going to give you that right now. It's a resin.
15 or 6 seconds.
So this is, you see the sleeve and everything else like that? That's the pressure infusion that's running in.
Okay, we're going to use a technique of holding the leg.
So he's pulling it back out now.
When we twist. IVs do this and that.
He said twist clockwise? Counterclockwise. I think you say clockwise. No.
So if you have the lock on there and you're twisting counterclockwise, isn't that just going to come off of that lock?
Typically, it does very, very well just by pulling it out that way.
Okay.
In terms of cleaning up afterwards, the idea of making sure it's good to go for the next round. All right, proximal tibia. Take a look.
Okay, the next landmark that we're going to use is our distal tibia. Will you identify
So medium malleosis, ankle bone. Check it out.
The clinician is going to put his ring finger or ring finger on that medial malleolus, 2 finger press up, and making sure you're on that nice flat section of the tibia. A great way to do it is to isolate the bone with either side with your fingers so you make sure that you're not too posterior sliding on the bone or to the interior. Once you've identified your landmarks, you're going to prep your hand just like you would for any IV, however your institution does it. With alcohol, chloroquine, whatever. 2 seconds to dry. Then what I'm going to do is I'm going to take my sterile needle container. I'm going to pop it. This is a magnetized tip. Put that on there. To remove the cap, I'm just going to twist it towards me. The cap is going to come off. Again, making sure that I can identify my black mark. So I've got my landmark, isolating my bone. Here's it at a 90-degree angle. I see my black mark. Okay. Take my black mark. Remove the stylet. Put it in a proof sharps container. I'm going to take my sterile lower lock tubing here. Attach it on.
And then I would take my 10 cc sterile flush, unclamp my tubing, and that's where I would do my
So the other connection you can have is that three-way stopcock that I talked about, and that would go right along with your extension tubing. That way you can run fluids or drugs off of one port. Proximal humerus.
Was this extra credit for paramedic test?
It turns out she is the daughter of the physician that you saw in the previous thing that's doing the same thing here. So I don't know how he got her to do it. So you can't hear the voice great. So we're just going to talk about it as we go.
I have to do this again.
Now, what they don't do a great thing is in terms of this demonstration is bringing that arm up across the chest. It should be up across the chest, so it actually opens up this joint right here,
Like a 90-degree angle.
like a 90-degree angle. Yep.
Now, were you looking at for your landmark for this one?
So it's hard to show you off of this right now, but the idea that you're going to bring a V down from the joint, okay? So it's two finger widths up from here. You're going to come down this way, and you're going to landmark it right about here on the flat side. And again, we'll show that to you tomorrow. So this arm should be bent across the chest. It's not. Look at the size of needle that he's using. Just like I talked about earlier. Look how small the she is.
Big buff dude holding her down.
So the other thing that maybe you can't see is that it's not butted against the skin. He stops at that black mark.
Gary, is that recommended?
Yeah. Yeah.
Will you feel the pressure release right here, the drill change?
Typically, it will go hand in hand with those marks, but the marks are a more accurate way of where you stop it.
I think she's witnessed this before.
So check this out. Now, humerus IO is in place, right? This is a radio cast for how quickly it gets to the heart. Watch. You know what? This is going to take us up to YouTube. I don't want to do that because that's going to mess up this taping. So anyways, what it's showing is that as you inject the dye into this, the idea is it's going to reach the heart somewhere around 2.5 seconds. So the sweet thing about it is if you want good access, this is it. What's the downside to this? Not really.
No, typically in cardiac or CPR situation, that's where
everybody's here, right? Everybody's here in terms of this, everybody's here in terms of this, right? So the idea, the opportunity to lose this along the way is probably the most common. But in terms of if you want the best location of the three, you want the best location, it should be this. You should be really, really careful about this.
How much longer does it take?
So this they claim is about 2.5 seconds. This is somewhere around 3.5, 4 seconds, something like that. So there's not that big difference. So check this out. The other thing that was being talked about when EVIOs first came out, or IOs in general, was about adenosine. And that adenosine, as you're going to find out, has a half-life of about 5 to 10 seconds. And so, to that, the thing was, will it get back to the heart in time to do its thing? As a matter of fact, yes, it will, just as good as the peripheral one along the way. So it isn't like there's that huge delay in terms of this versus this, but it gets consideration in terms of where you're going.
So with the total IO going off the landmark, you said the across the
Yeah.
I do that and find the landmark. As soon as I move my house back, it'll rotate back.
That's why you're going to leave that arm planted there once you're doing the humeral IO. You do not move it until you're done with it.
And after you're done inserting the IO, you can move on.
Yeah. So this is the bone injection side. Let's see the plays. This was the one earlier today that was giving me problems about playing, so maybe now. There we go. The difference with this is that it's kind of more of a push force than a drill per se. But the same location as far as sight. So let's put our hands all over it and then let's push it in. By the way, these needles, the adult-sized needles, and the same thing for these right here. These are about 15 gauge needles. So that's a different variety. And finally, this is the one that is fairly new on the market. It is kind of similar to the last one that you saw.
The IVIIO intraosseous device functions differently from manual and drill-based devices in that the design is not based off needle length, but rather proximity to the bone when the needle is deployed. When deploying the needle, the user is required to apply firm pressure with the palm of their hand. This is part of the 3-step safety feature to prevent accidental deployment, but also serves another purpose. The pressure applied causes localized compression at the insertion site, shortening the distance the needle needs to travel. With this design, the IVIIO adult is able to cover the full adult range, from average average size to those in the bariatric range on both the proximal tibia and humerus. As long as the user can physically palpate the landmark with their finger, they can successfully deploy the NEO.
So I'm trying to get my hands on that. Boundtree came and demonstrated that to us a couple months ago. I'm trying to see if we can't get a couple samples for you to take a look at. So finally, last but certainly not least, there is a sternal IO. Have you seen this before? Maybe, maybe not. It's a military guy. I'll give you a hint. Okay. No, as a matter of fact, they're not. So check this out. The difference being that anything else we're talking about, it's a sternal IO, so it sits right about there. Why would they do that in the military? So that's where primary being. Yeah, that's exactly it. The idea in terms of the IEDs and the likes of the idea in terms of sternal IO, they're training everybody. They're training everybody that they can do this in under 10 seconds. So, okay? That's their go-to method. It's not IED, it's not anything along the way. That's their go-to method in terms of somebody being injured in the battlefield. Okay. Yeah.
Is there a reason we don't train these?
So the answer is of all the ones we're talking about, it probably has the most complications. Let me tell you my war story. It's the one and only time that I've seen it used. I've never had it in my hand and started using it, but I will tell you that I had a critical burn patient that a certain helicopter service around here was carrying at the time. And so as they went to use the sternal IO on this gentleman, they actually bent the needle in his chest. I was convicted that at that point that probably that is not a device that I want to use.
Because that was just because of the problem.
Probably. But I don't really want to go any further with it. Yeah. So I think it's got its use, and I think the military has shown that it's got its use along the way, but I think it's got some complications along the way as well. Make sense? All right, so take a look.
You got this, guys. You got it. You can do it.
So what it means is it's got this port coming off right here. Okay? And so the idea
How long am I going to record for?
It sounded great. It sounded great.
It is the cartilage kind of breaks off there. I mean, that was a pretty big pop down.
I wish I could tell you that. I don't know enough about it to even go there with you. So maybe. That's enough of that. Questions? So you again, like with IV, you need to know about indications for IO. You need to know about contraindications. You need to know about, especially with easy IO, because that's the one that we'll be primarily talking about here. You need to know about the 3 different landmarks that we're going to use for setting up. And then eventually, I will ask you how you do it, how you set it up, but that will be after you get your hands on it and play around a little bit as well. Yeah.
IO geriatric patients.
Yeah. So all by themselves, geriatric patients are not a kind of indication. But you're going along with the idea they're septic or you're infection in an area, certainly would get your attention. But all by itself, osteoporosis might. So osteoporosis is a relative contraindication. That is, you may or may not know they've got osteoporosis. So the idea of going with it until you know differently, sometimes you're stuck in that rock and a hard place. Anybody else? That's enough for the afternoon, wouldn't you say?
You said now you're talking.